The next thing we have to talk about here is this thing called significant figures, and this is a phrase that for some reason gives a lot of science students, or let's say former science students, a nervous tick. I never understood why, because it's really not that complicated. So here's the definition. It is all digits whose value are known without estimation, and we call that uncertainty. And the first one that is uncertain, let me guess, that did not clarify this at all for you. I understand, don't feel bad. Let's go to a picture that gives you an example. So now we're going to talk about, measured or observed values, because as we talked about earlier, chemistry is an observational scientist. So let's say you were tasked with measuring the edge length of this rectangular object, and you had two rulers represented here, and let's pretend that these are centimeters. Intuitively, which one do you think is going to give you a better answer? Hit pause, take a minute to think about it, come back. Yeah, let me guess. You, in all likelihood, said this one. And why is that? So when this class is face-to-face, I have a fun time asking people this because they try to put into words this very basic concept that they know deep inside, but it's hard to verbalize it. It's because of the lines, right? So there are more lines on this ruler than there are in this one. So scientists have this habit of making things that are very simple and rendering them almost unrecognizable by giving them new names. And so these lines actually have a name. And they are called graduations. And we often describe a measuring device, like our rulers here, by how many graduations they have. And in particular, by we rank them by the smallest space between two graduations. So for example, this one right here, or the ruler on the left here, would be said to have 1 centimeter graduations because there is 1 centimeter between lines. So now, with that piece of information, what I want you to think about is what is the graduations, or how graduated is the other ruler, the one on the right. Now, so the idea here is that there are plenty of lines between, let's say, so in here, there are no lines between the 1 and the 2 centimeter marks. In here, there are many lines. In fact, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 little marks between in the space of 1 centimeter. So we would refer this ruler as having 10th centimeter graduations. The smallest graduations are a 10th of a centimeter apart. And usually, more graduations implies that you can get a more accurate reading from that device. Now, how is that reflected? So let me ask you to write down, or to think about, let's go back to our bad ruler here. What would you write for your answer? What is the position of the right edge of the rectangle? Now, I would often have people come up on the board and write this. Now, what they would not say is that, almost no one would say 4 centimeters or 5 centimeters. they would say something in between. The average answer would probably be 4.5 centimeters. Now, some people might say 4.4, some people might say 4.6. I don't think anyone would say 4.7 or 4.8. So what happened here? Well, clearly, you estimated, right? Because you know that there's this big gap here. It's about halfway between the two, so you probably tacked on the 0.5 to indicate that the halfway between 4 and 5. All right, let's go back to significant figures. So what was the definition? They were the digits whose value are known without estimation. So that means the numbers that have a line. So it's not really an estimation that this edge length is beyond the 4 centimeter mark and that it is before the 5 centimeter mark. So the 4 is known without estimation. But the 0.5 is the one you estimated. So this measurement right here is said to have two significant figures. Now, what would you say here? Now, I should note that these objects are the same, the blue rectangles are the same exact size, and they are placed at the same exact position on the rulers. Now, I would ask you to give me a reading for here. And here you can look at it. Now, the difference here is that you've got many more graduations, right? So right now you can see that the edge is actually beyond. The 4.5 mark is this one right here. The edge is beyond that. So what would you write down as the position of the right edge of that rectangle if you use this? Hopefully, you would give me something like this. I said 4.53. It's a little past the 4.5 mark, but not halfway. So you could say 4.52, you could say 4.54, you would be all right. But the idea is that these lines actually allowed you to estimate more. Now, the uncertainty in either of these measurements when they are reported honestly is that they are plus or minus 1 in the last reported digit. The question is, how many digits do you report it to? You will note that here we reported it to 1/10 of a centimeter. Here we reported it to 100th. It turns out that the human eye and brain put together are very good at breaking up any gap into 10 parts. And whether that gap is relatively large like this or relatively small like this, you can break it up into tenths. Not much more than that. And this is the idea behind what we call the 10% rule. And it is simply that. And this tells you how we report measured values. And bottom line is that it's assumed that you can reasonably estimate to 1 decimal place beyond the smallest graduation, because humans are good at doing that, but nothing beyond that. Yeah, you can break this down into 10 separate spots, but not 100. So here, 1 centimeter graduations, we reported it to 1/10 of a centimeter. 10th centimeter graduations, we report to 100. So let's talk about sig figs, right? So the 1's place is known without estimation. The 10th place is known without estimation. Clearly, you've got the line to tell you where it is. It is beyond the 5, but not quite to the 6. So the 4 is known without estimation. The 5 is known without estimation. The 3 is the one you estimated. And you're allowed to estimate 1 digit, and then you can stop. So how graduated something is will determine how many decimal places you report an answer to. So remember, a tenth more. Okay, this looks like it's the same thing, but it's not. You might have seen a slight shift. So it is still the same object, but now I moved it ever so slightly to the left to point out. So in this case, you might be inclined to say 4.5. But in this case, the proper answer is now 4.50. So I engineered it so clearly the right edge is right smack dab on the 4.5 mark. If that is the case, and you are sure that it's 4.5 and not 4.49 or 4.51, you're estimating it to be exactly on the 0, you need to include that. So that 0 is significant. So again, if it's right on the graduation, report it. How's the way to, this is a common error. What's a good way to catch it? If you are making repeated measurements from the same device, presumably the same graduations, they should all have the same number of decimal places. So for example, if you were measuring a bunch of lengths with this ruler, you would report, for example, 4.51, 4.59, 4.52. And so if you have one in your column that has one fewer decimal places, that means you probably, was a case like this where that last decimal place was 0, and you should write it as such. So don't do this. So let's see if you get the hang of this. So reported values. And so the idea is that if you're reporting a measured value to the proper number of significant figures, then that will give someone else a good idea of the uncertainty in that measurement. And that is a piece of information that scientists like to convey. So what I want to ask you is, I want to ask you to do this problem in reverse. I'm giving you two temperature readings here, 35 degrees Celsius and 35.29 degrees Celsius. And what I want you to do is tell me what graduations these two thermometers had, based on the number of decimal places that are reported. And I will tell you that probably most students had an easier time starting with the second one. All right, so hopefully you've had a minute to think about it. Now, again, the rule is that we report to a tenth more than what the graduations are. So if this one was reported to the 100th place, that implies that the graduations on the thermometer were actually to the 10th place. So this thermometer has readings every 10th of a degree Celsius. And I will tell you that is a very, very, very expensive thermometer, a couple $100. This other one here, it is reported to the 1's place, single degree Celsius. So if you're reporting to a tenth of that, that implies that this thermometer has markings every 10 degrees Celsius. This would be a pretty bad thermometer, not the most useful thing in the world. Right, so again, this is how to convert from a reported value to the uncertainty. So the implication here is that this reading is probably good to plus or minus 1/100th of a degree Celsius. This one is probably good to plus or minus 1 degree Celsius.